Term relative mean? Relative. Different than absolute. And relative means it depends on what's around it. It depends on the context, okay? For example, if you say I'm tall, that's a relative term. You're comparing yourself to the height of other people, right? If you were in a room with a bunch of tall people and that were taller than you, okay, let's say, for example, you're 6 foot or 6'2". Okay, you're pretty tall, right? But if you go to like an NBA game and everybody's like almost 7 foot, then you wouldn't be really tall anymore. It's a relative term. So in terms of this lesson, you've got some points on the graph that might be higher than others, for example, this point. But if we look at the totality, it looks like there's points over here that are even higher, right? Certainly we could say this point is relatively tall, but it's still not the tallest point on the graph. So the word extrema just means kind of like an extreme point. So we're talking about relative extrema on a graph. All right. So I'm going to go ahead and tell you guys what the two extrema are here. And maybe you can figure out why they are. This one's going to be a relative max. I mean, you could just draw the general shape of the graph. It doesn't matter. And this one we're going to call a relative min. Now, if you notice, the relative max is not the highest point on the graph, is it? There are points over here that are higher than that. And the relative min is also not the smallest point. There's points down here that are smaller. So what do you think makes it a relative min or max? Well, without me actually, kind of plotting a point there, it's still a point on the graph. It's just more pronounced. Anybody want to tell me why the relative min and max? I'll give you a hint. It transitions from something.
The highest constant, lowest constant?
Okay. Let me go ahead and tell you. A relative max is where it goes from increasing to decreasing. Okay? And it doesn't have to be curvy. If it went like that, this point right here would still be a relative max because it goes from increasing to decreasing. Pretty simple, right? So what do you think a relative min is? Goes from decreasing to increasing.
So if it doesn't go to increasing, there's like a relative minimum.
Right. If it were to go to decreasing and then something else happened, let's say it ended up flattening out, it would not be a relative min. It has to transition from decreasing to increasing. Now, we're going to go over several definitions together. You don't have to write them all down. The first one is probably the simplest. You could say the high and low points of a function. Now, notice that we're not saying the absolute highest, we're not saying the absolute lowest. We're saying high and low points. Going back to hiking, which I enjoy doing, sometimes when you go on a hike and you're trying to climb a mountain, you'll reach a certain smaller peak and then you have to go down before you can go up again. That would be a relative max. Now, I do want you to write the actual definition. So this middle definition is probably the most accurate and says that the function continuously goes from increasing to decreasing. That is what a relative maximum is. The word continuous means there's no break in the graph, okay? Just imagine it being a string, a continuous string. If there is a break, then it's not a relative maximum. The third definition is that the points just to the left and right are lower. Maybe that one helps the most. If you look at a point on the graph and the points just to the left and just to the right are lower, then it's got to be a relative max because it's bigger than all the points around it. Okay, any questions about that? That'll lead us to relative minimum.